Alright guys, I hope my videos are helpful. Please, if you're new to this channel, subscribe and help this channel grow. And I would like for you guys to give recommendations or suggestions. I know my videos suck. And but what I'm gonna do for the rest of these graphs, because I don't wanna, my brain's already fried. I don't want to have to keep reinterpreting this, redrawing the motion graph. And I think it's better off if I just give the solution manual for you guys. So for the rest of a lot of these problems, I'm just gonna pull up the solution for you guys, so you guys can look at the solutions. And and if you're taking a class, hopefully that helps. All right, here it is for you guys. This is the solution, number 46. And no, I do not take credit for this. I did not solve this. I did not wrote this. This is from somebody else who I have no idea who. So this is just from what I have. I have all the solutions from the book, by the way, which is really nice. So that means I get to check my answers. But I usually just look at the even solution. I never really look at the solution manual. So let's read this. Directly above the graph, sketch the graph of the position versus time graph. All right, so you have the velocity, you have the constant change of velocity, so that's going to be a parabola. And then it's going to go from that to a constant velocity. So from 2 to 3 seconds, you're going to have a parabola, and then you're going to have a straight line from 3 to 5 seconds. So this is going to be a straight line, and then from there, it's going to have some negative velocity. So at 7, that's when the velocity is 0. And it's going to travel, so it's still going to go up to that point, and it's going to come back down. So, and B is sketch the graph of the acceleration versus time. Well, here the acceleration, that's going to be 8/3, whatever that is. So that acceleration is just going to be, it's going to be this, and then it's going to be 0, and then it's going to be some negative acceleration, which is we can find that. That's 16 divided by, what's it, between 5 and 9. That's 4. So that looks like it's going to be 4. And 8/3 is going to be 2.60. So that's part B, folks. So part A is sketch the position. Part B is sketch the velocity versus time. And this is the graph. And I'm so glad I'm pulling the solution manual. It actually relaxes me a bit more. And for part C, what is the acceleration at t equals 6? So at t equals 6, that's just going to be -4. So for part C, it's going to be -4. And the position relative to the starting point at t equals 6, I don't want to have to like do geometry or like for this. But you know, you could find the area underneath between here and this point, and that should get you to 34 meters. And what is the moped's final position at night? So that's basically looking at this area minus that little portion of the area, which I think I might be able to, well, I don't want to try and do that, but that's going to be 28 meters. So, you know, just understand that the position is the area underneath the velocity and the time, because it's really just the sum up of a bunch of rectangles of the individual velocities, whatever that speed is, over that tiny time interval, and you add them all up. So that's why it results to the area. Whatever method works for you guys. All right. Hope this helped.